All right, so for numbers 6 through 10, we're going to go to the second passage, which starts on page 3. So, let's start here. If a student used a 30-centimeter long string to construct the pendulum, the average time for the pendulum to complete 10 oscillations would most likely be. So, we need to figure out here length of string, where this would go. So 30 would fit right in between 25 and 37.5. And then we need to see the time that it would calculate here. And then we'll look through these tables. So again, we're actually going to go to table 1 for this one. So 30 would go right here. Time to complete 10 oscillations. So these are somewhere between 10.1 and 10.6. And the 37.5 is somewhere between 12.1 and 12.8. So our numbers are going to be between, let's just take the middle numbers of these, let's say like 10.4-ish and then 10.5. But it's also going to be a little bit on, or 12.5. It's going to be a little bit closer to the 10 range because 30 is closer to 25 than it is to 37. So in between 10.4 and 12.4 seconds, our answer there is going to be C. Based on the passage, what length of string should be used to produce a simple pendulum with a period of 2 seconds? The string should be. So we want the period to be 2 seconds. So we're going to make sure that we're just skimming this passage to see if we need any of this information, but I think we can go straight to the table. So, based on the passage, what length of string should be used to produce a simple pendulum with a period of 2 seconds? The string should be. Now, I want the period to be 2 seconds. So if I look here, these are increasing, and so I want the period to be right here at flat out 2 seconds. So that means my numbers are going to be between 87.5 and 100. So somewhere here, my answer is on this X line. But you see our answer choices don't give us a specific number, they give us that range. So we say the numbers that it would fall between, our answer is C. So this passage is actually quite a lot more simple than your passage before. But the steps are still the same. So you find your variables and their trends. And then you locate the number in the question. And then you locate where that number would fall in the table. And remember, you will never ever be given that number. It will always be a prediction that you make for the second number. According to table 2, so I know I'm looking at table 2, which of the following is most likely the calculated acceleration due to gravity? So that's the variable that I'm looking for at the table. That's what I'm asking for a simple pendulum made with a 20-centimeter long string. Now, we're not going to see this number. What we're going to see is where it would fall. So a 20-centimeter long string would fall about here, 20 centimeters. So that means that if I go over to calculated acceleration, I can literally trace that. I'm going to be between, does that say 8? Yes. 8.95 and 9.14. So then here, according to table 2, which of the following is most likely the calculated acceleration due to gravity for a simple pendulum with a 20-centimeter long string? So right there, these are the two values that it's going to be between. So the answer to number 8 is actually A. All right, number 9. Based on table 2, which of the following most accurately represents 9.42 meters per second squared as a percent of standard acceleration due to gravity? So 9.42 meters per second squared. So where would this lie? So I'm going to put it, oh, you know what? I lied to you. So let's go back to number 8. So what I did is I actually missed a step here. So the answer is not A. This is your distractor. And that's what happens if you don't look at both trends. So here, this is 8.95, 9.14, 9.64. So this is an increase, increase, decrease, increase, increase, decrease, decrease. So what I failed to do, and why A is the distractor, is because if you look just between these two values without looking at the trend first, so I found the variables, but I didn't find the trend. So if we go back to number 8, the answer is actually going to be D, because acceleration does not have a trend. And then A is the distractor, because that means you looked at two values but not the whole trend. All right, going back to number 9. Based on the table, which of the following most accurately represents 9.42 as a percent? So here what we're going to do is we're going to order this. So I'm going to do 9.10, 9.12, 9.14, 8.95. So that's 91.2, 92.8, 93, and we're seeing a trend actually does emerge between these ones, 93.2, and the number that we're looking for is 9.42. So we can go here, let's see, 9.25 is 94.3, 9.26 is 94.4, so I've got that one, that one, that one, that one, that one, that one. Now we're at 9.33 is 95.1, 9.64 is 98.3. Okay, so now that I've reordered this table right here in the proper order, which is something that you will need to do, now what we're looking for is 9.42. So that means our answer is going to be between 95.1 and 98. So the answer to 9 is D. All right, number 10. Based on the passage, a simple, so I'm going to add in a step here too. Order from increasing to decreasing or vice versa. So make sure you put it in the right order. Now, based on the passage, a simple pendulum would 55 centimeter long string, so that would go right here. This is already in order, and so we can follow the trend here exactly too, because these are increasing and these are increasing. So as long as one of these is in order, you should be fine. There, so let's look at the trend here first. This is increasing, so we can look at that. 55, that means it's going to go between 1.47 and 1.63. Our answer will be somewhere here. So 1.36 is too low. 1.71 and 1.86 are too high. So the answer to number 10 is B.